We have a uniform motion problem here. Gabby is a pilot for Crossland Airways. She computes her flight time against a headwind for a trip of 2,900 miles at 5 hours. The flight would take 4 hours and 50 minutes if the wind were half as great. Find the headwind and the plane's airspeed. So we're looking for an airspeed, which is a rate, and we have our flight times of 5 hours and 4 hours and 50 minutes. And we have a distance. So we're talking about a uniform motion problem, which is a distance, rate, and time. So we're going to need to make a chart where we have our distance at the top, our rate, and our time. And then we're going to be talking about going against a headwind, and then against a headwind if the headwind were half as great. So here we have the headwind, and then we're going to have, I'm just going to call it half the headwind. And we're going to be doing a total of 2,900 miles for both cases. So my distance for both is 2,900. The other thing I know about both is their time. So when the headwind is at full force, it's going to be 5 hours. And when the headwind is at half speed, it's going to be 4 hours and 50 minutes. Now we need to change this to all hours. And the reason we're changing it to all hours is that, remember, our rate is going to be in miles per hour. So we need to change this, and it becomes 4 hours and 50 out of 60 minutes, which we can then reduce to 4 and 5 6 hours. And it might be easier then to also rewrite this as an improper fraction. 6 times 4 is 24, plus 5 is 29, so 29/6 hours. Then we have to figure out our rate. So the flight would take, okay, if the headwind were half as great. And then it says find the headwind and the plane's airspeed. Well, I know the plane's airspeed is going to be smaller or less when I have a headwind going. So that means I'm going to have my regular rate, and then I'm going to have to subtract from that my headwind. And the same thing down here. Well, this is going to be half the headwind of this first one. So if I make this one W for wind, then this one's going to have to be 2W. That way this is half of this wind right here. So remember, the rate of the airplane is going to be diminished or decreased by the headwind. It's going to make it go slower. So now we need to remember that we have our equation here, and we know that D is equal to RT. So we know that 2,900, my first equation, is going to be equal to R minus 2W times T, which is 5. And using my distributive property then, we're going to end up with 2,900 equals, and I need to use the distributive property where I multiply 5 times R and 5 times 2W. So that gives me 5R minus 10W. So that's my one equation. My second equation is going to be 2,900 is equal to my rate, R minus W. And then on this particular problem, I'm going to use my 29/6 hours. So I'm going to write 29/6. And then using my distributive property for that one, I come up with 2,900 equals 29/6R minus 29/6W. Now I want to get rid of these fractions before I go any further. So to do that, I'm going to multiply everything by my common denominator, or my LCD, which is 6. So I'm going to multiply 2,900 by 6. I'm going to multiply each one of these terms by 6. When I do that, I end up with 17,400 equal to, so 6 times 2,900 is 17,400. 6 times 29/6R is 29R. And then 6 times 29/6W is minus 29W. So that's my second equation. And then my first equation I'm going to rewrite underneath here. Now I'm going to use elimination, and I'm trying to figure out if I have any sign changes between my variables, and I don't. And then I'm going to try to figure out if I have any nice LCMs between 29 and 5, and there's nothing really nice about anything. So I'm going to try to get rid of my r's. That means I need to multiply my first equation by a 5, and my second equation I'm going to multiply by 29 to get my correct LCM. And then I'm also going to make my 5 up here, I'm going to make that negative because I need to make sure that I have a sign change with my r's. So when I do that, I end up with negative 87,000 equals negative 145r plus 145w. And then the second equation becomes 84,100 equals 145r minus 290w. So now when I add these two equations together, the r's should cancel out, and I'm left over with negative 2,900 equals, and then adding my w's, negative 145w. I'm going to divide both sides by 145. Oops, a negative 145. And I end up with w is equal to 20. Now remember, what was w representing? It was representing our wind, and so then our wind is going to be 20 miles per hour. So that answers this question right here. Find the headwind, because w is representing my headwind. Now I need to find the airplane's speed. So to do that, I'm going to substitute in w, 20 for w, into one of my equations, and I'll probably just pick this second equation. It looks like the easiest. So doing that, I'm going to have 2,900 equals 5r minus 10 times w, which is 20. Multiplying that out, 2,900 equals 5r minus 200. I'm going to add 200 to both sides, and I end up with 3,100 equals 5r. Dividing by 5 on both sides, I end up with r is equal to 620. So remember, r was representing the speed of my plane. So now I know the speed of my plane, and I know the wind, and by the way, that looks like a reasonable speed for a plane. So my headwind, so I'll just write this all down together, headwind, we found, was equal to 20 miles per hour, and the plane speed in still air was equal to 620 miles per hour.